Hello calculus students, welcome to video 4D. This video is on implicit differentiation. Time for something new. So first, let's talk about the difference between explicit functions and implicit functions. An explicit function is what we're used to dealing with. It's a function that's already solved for y. And if I gave you a value of x, like x equals 2, all we have to do is substitute it in the formula to find y. So in this case, y would be 2 squared minus 2 times 2 plus 3, which I guess is just 3. That's an explicit formula, okay? Well, we also have functions and curves defined by implicit functions. And that means that it's not really solved for y. We can put in a value of x, like if I put in x equals 2, 2 squared would be 4 times y, plus 2y squared equals 2 times 2, which is 4. So I can substitute a value for x, but if I want to know y, I have to do some work. I have to solve it for y. So that's an implicit function. It's not already solved for y. Okay, so explicit functions are very nice, right? We can just take the derivative of it. Implicit functions occur in life also, and we have to be able to handle them. So let's do some examples. So here's an example. This is actually an ellipse, and we want to find the derivative at this blue point right there. So that point is actually 1.6 comma 0.6, and we're going to find the derivative there. We can tell it should be negative, right? It's kind of, the slope is going down right there. So this is how we do this. There's a trick for this. What we do is we take the derivative of the entire equation. So if x squared plus 4y squared equals 4, the derivative of x squared plus the derivative of 4y squared has to equal the derivative of 4. Take the derivative of everything. So this first term, when I take the derivative, I get 2x, okay, plus I have to take the derivative of this term. Now when I do it, I have to remember that y is a function of x. What I really have here is 4y of x squared, like that. And I need the chain rule. So it's going to be 2 times 4 is 8. Y to the first power times y prime. Okay, that's using a chain rule. 2 times 4 times the function to the 1 less power times the derivative of the inside function equals, the derivative of 4 is 0. So let me rewrite. I get 2x plus 8y, I don't need the exponent 1, times y prime equals 0. So what happens after we take the derivative of everything is we get an equation where we can solve for y prime. That's our goal, find the derivative. So I can subtract 2x from both sides. If I subtract 2x, I get 8y times y prime equals negative 2x. And I'm going to divide by 8y. And so finally I get y prime is negative 2x over 8y. I can cancel 2, so I get minus x over 4y. That's a formula for the derivative for any point on the ellipse. And now we can substitute in the point we have. So if I put in what we have minus x would be minus 1.6 divided by 4 times 0.6, which is 2.4. Get kind of a decimal here. Let me grab my calculator. And we get 2/3, actually, or negative 2/3. So we get minus 0.6666, which is negative 2/3. All right, that's the slope of the tangent line right there. Negative 2/3. Okay, gotta do a few of these till you get used to it. The curves that defined by implicit functions are kind of cool. This is a hyperbola here, and we want to find the derivative at the blue point. Okay, so let me rewrite it, kind of what I was doing last time. So at first, sometimes it's helpful for students to write it like this. So that's what we really have here. We have x squared minus y, which is a function of x squared, equals 16. Now we take the derivative of everything. We have 2x minus 2 times y of x to the first times y prime equals 0. Or, more simply, 2x minus 2y times y prime is 0. So I'm going to subtract 2x from both sides. I'm going to divide by negative 2y. And the negative 2's cancel. We get y prime equals x over y. That's the formula for the derivative. So at this point here, which is 5, negative 3, all I have to do is substitute 5 for x and negative 3 for y. Apparently, the slope there is 5 over negative 3, which is negative 5/3. That's the slope there. Yeah, it makes sense. It looks like it would be negative. All right, let's keep going. What else can happen? Let's use the product rule for this one. So remember, the product rule is f prime g plus f g prime. All right, so f is x here. So f prime would be 1 times g, which is y, plus f, which is x, times g prime, which is y prime. That's the derivative of that. Plus, we need the derivative of y, that's y prime, equals the derivative of 9, which is 0. Okay, now, this is some algebra. Pretty much what we have to do is get everything without y prime on the right side. So we'll get x, y prime plus y prime equals minus y. I subtracted that term from both sides. Then I factor y prime out of what we have here. So y prime times x plus 1 equals minus y. So I just factored out the y prime, and now I divide by x plus 1. I get y prime equals minus y over x plus 1. So a lot of steps here. The first step is making sure we can take the derivative correctly and use the rules of derivatives. Second step is make sure we can solve for y prime. Okay, and once we have that done, we can plug in the point. So y prime equals minus y, that would be minus 3, over x plus 1, that would be 2 plus 1, and that equals negative 1. So another negative slope. Slope there is negative 1. All right, I think we have 2 examples left. So this is kind of a weird function. It has this piece here and this piece here, and it actually has a little piece that connects them. Kind of a weird curve. All right, now this one's kind of advanced. We're going to need the product rule twice because this is a product and that's a product too. So f prime g plus f g prime. That's the product rule. Okay, let's do it first for this guy. F prime would be 2x times g, which is y, plus f, which is x squared, times g prime, which is y prime. Plus, now we got the product rule for this guy. Same rule. F prime would be 1, g would be y squared, plus f times g prime. Now we need the chain rule here. Remember, this is a function squared. So it would be times 2y to the first y prime, and this equals the derivative of 2x, which is 2. Okay, now, wow, once that's done, we got to solve for y prime. These terms have a y prime, so I'm going to keep them. And these terms here, we're going to move to the other side. So we get x squared y prime plus, this is 2xy, y prime equals 2 minus 2xy minus y squared. Okay, factor out the y prime. That's what we got to do when it's in more than one term. Equals this mess on the right side. And we just got to divide by this. So y prime equals 2 minus 2xy minus y squared over x squared plus 2xy. Holy cow. Now, we can evaluate that at 1, 1. Let's not and say we did, okay? Now it's time for the journal assignment. So the ones for a journal assignment aren't too bad. This first one is very much like the first 2 examples. So almost identical. You got, when you take the derivative of y squared, remember that that part is going to be 2y prime. Okay? And then here, you need the product rule to take the derivative of that. So take the derivative and solve for y prime. Okay. Well, give it your best shot, and we'll be working on it, and you'll be masters of this in no time. See you later.